Well, we have another question here. The question says that given a geometric sequence 36, -18, 9, determine the value of the common ratio. This is 2.2.1. Right here. 2.2.1. So we're looking for R, the value of the common ratio. That's R. I said that because the question says a geometric sequence. Okay, so R is given by R equal to Tn over Tn minus 1. So I want to say R will be equal to -18 over Tn minus 1 is the previous term. Okay, so 30 over 36. That means R will be equal to -1/2 or 0.5. Okay. Okay, my tool looks a bit not okay there, but let me make it look nicer. Okay, -1/2 or -0.5. Now, the following question is question 2.2.2. It says that if Tn equal to 6, actually 9 over 4096, calculate the value of n. So 2.2.2. So we're looking for n. If Tn equal to 9 over 4096. All right. Because it is a geometric sequence, Tn, we know Tn in geometric sequence is given by a r to the power of n minus 1. Okay, so we can say that we know the first term here, a is the first term is 36, and then r, we just find r is -1/2, so we can substitute that. Okay, so therefore Tn will be equal to a, the first term 36, and then r is -1/2, okay, to the power of n minus 1, and then Tn is also 9 over 4096. So we're going to equate the contents. Tn is this, Tn is also that, so we're going to equate them. So we're going to say 36 times -1/2 to the power of n minus 1 equal to 9 over 4096. We can divide both sides by 36. So it means if I divide here by 36, it means I'll times the denominator here by 36. Okay, and then so this is going to be just -1/2 to the power of n minus 1 equal to we can simplify because I know 9 gets into 36 4 times, so I can cross here. It's going to be 1 across there. It's going to be 4, and now this will be 1 over 4096 times 4 is just let's do it here. 4096 times 4 is 16384. So 16384, and then this number here, 16384. Okay, what can we do then? Oof, quite tricky. We can write this denominator here, 16384, in terms of its prime factor. Okay, so now let's see. This is what you can do. You press equal, and then you press the button shift, and then you press the button fact. This button here, fact, and then this tells us this is 2 to the power of 14. So this is like it's like we have like -1/2 to the power, okay, to the power of n minus 1 equal to 1 over 2 to the power of 14. Okay. I'm gonna move my board a little bit this way. Split it like that. So now this is gonna be like negative a half to the power of n minus 1 equal to a half to the power of 14. Okay, we can write like that. Why am I saying so? Because one can have any exponent. So we can write like 1 to the power of 14, okay, over 2 to the power of 14. We can write like that. And then because the 1 to the power of 14 just 14, actually, excuse me, 1 to the power of 14 just 1. So this can be written as then negative a half to the power of n minus 1 equal to a half to the power of 14. Now, how can we do that? Because here it's negative a half and that's positive a half. How can we transform this? Okay, because I know you and I both have in mind the law of exponent that says if a is to the power of m equal to a to the power of n, this implies that m equals to n. But the challenge that we have is like this is a half, this is negative a half, and then that is a half. We cannot really apply this law. But what can we do then? Okay, there's another way out. You know, when on the right here, negative a half to the power of n minus 1. Okay, n minus 1 equal to over here, when the exponent is even, you know, the base can be positive or negative, it's still going to be the same thing. So this is the same as it will be the same thing as if it was negative a half to the power of 14. Okay, if you try, because the exponent is even, 14 is an even number. Okay, so negative a half to the power of 14 is equivalent to a half, positive a half to the power of 14. Now that we have the two bases equal, we can apply the law of exponent that I mentioned there in red. We can cross the bases, and then this will be n minus 1 equal to 14. And then if I move the negative 1 over, that makes n equal to 14 plus 1, which means n equal to 15. So that's the value of n. Okay. Now the following question says, let's see, question 2.2.3. The question says calculate s to the infinite s. Okay, this sum, okay, because the set converges. Now, let me move the board this way, and then this expression I can take it somewhere there because of space. Now, let's see here question 2.2.3. We are looking for s infinite. Okay, we do know that this sum is given by s to the infinite is given by a over 1 minus r. And then we know what a was. A is equal to 36, okay, over 1 minus r. R is negative a half, so r negative a half. And then positive, negative minus minus will make positive, so this makes s infinite will be 36 over 1 plus a half is 3 over 2. 3 over 2, and then this will be s to infinite will be equal to 36 times 2 over 3. And then we can use the calculator here, or we just solve this, because as you know, 36 and 3, so you're left with 12. 12 times 2 is 24. So the sum to the infinite will be equal to 24. So s infinite will be equal to 24. Okay, and then the other question 2.4. Hola. Question 2.4, the question says that calculate the value of T1 plus T3 plus T5 plus T7 plus T499 over T2 plus T4 plus T6 plus T8 plus to T500. Quite interesting question. How can we do that? Well, you can notice something here, that the numerator here are the odd numbers, okay, are the odd terms, okay, are odd, and at the denominators here, the terms at the denominator are even. So this one are even. Now, okay. Now you'll notice that so we can just do the sum of the odd numbers over the sum of the actually the sum of the odd terms over the sum of the even terms. Okay, so I'm gonna write the question here, 2.4. 2.2.4, I mean, we are looking for the value of T1 plus T3 plus T5 plus plus T499 all over T2 plus T4 plus T6 plus plus T500. So there are like 500 terms. The numerators here are the sum of the odd. Okay, the numerator here consists of I can do this one, sum of odds terms. Okay, and the denominator here consists of the sum of the even terms. So okay, sum of even terms. So now let's do it. I think I need space. I can just move my board there. Okay, I still have space here underneath. So we can do sum of odds, the numerator. Okay, odd terms will be given by, okay, because we do know that the sum, okay, let's first write the sum formula. The sum will be A open brackets 1 minus R to the n all over 1 minus R, okay? So now if I need to work out sum of the numerator, okay, the numerator, which is sum of the odd numbers, it will be equal to A. The first term is term 1. First of all, how can we do that? Because I cannot just say sum of the numerator. Okay, sum of the numerator. Okay, let's say this. I can say that sum of the numerator is sum of odds, now odds terms. Okay, which is then how many terms are here? If we count the terms 1, 3, 5 to 499, the total number of the terms is 250, because it's 500 divided by 2. It's 250 terms. So this will be equal to, using this that formula, it's going to be the first term A, 36, open brackets, 1 minus negative a half to the power of n. Okay, let's use square brackets here. All over 1 minus a half, okay, something like that. So this will be S250 will be equal to 36 plus now Now something changed also. Okay, not this way exactly. Hold on, give me a second. I just want to adjust this. So far so good, but I also want you to notice that if I want to consider the two as separated sums, the constant ratio will also change, because first of all we had the constant ratio was -1/2, but now that the second term is term 3, the third term is term 5, the constant ratio will be -1/2 times -1/2. I don't know if you are with me. Okay, so it's like the terms are now like this. They are like 36, and then it's not -18 anymore, because this was T2. Okay, that's T1. I just want to make you understand this. And then 9 is T3, and then it was the following term was T4 was then -9/2, etc., like that. But now, if I consider T1 and T3, so the terms now are like 36, okay, 9, and then etc. So now the constant ratio here will be 9/36, which is equal to a quarter. Okay, so the constant ratio is no longer -1/2 but a quarter, because -1/2 times by -1/2 makes a quarter. Now this will be then so about that right here, this would be S250 would be equal to A36, the first term, okay, open square brackets, and then 1 minus the constant ratio, which is now a quarter to the power of n, close brackets, all over 1 minus a quarter. So this would be equal to 36, open square brackets. Okay, n is no longer n, but now 250. 250, because we're doing sum of 250 elements. And now we can just use the calculator to find this value. Okay. S250 will be equal to, let's use the calculator. What is it? So right here, 36, open brackets, 1 minus open brackets, a quarter, okay, a quarter, close bracket, to the power of 250, okay, and then close brackets, all over 1 minus a quarter. So when we hit equal, and then we had the answer here is equal to 48. This is the sum of the numerator, okay, the odd term. Now let's do the other terms. Will be 250. The sum of the denominator, 250, will be the first term, and the denominator will be -18 now, because this is the sum of the even terms. So that's going to be -18, open square bracket, 1 minus a quarter still, because the ratio will be to the power of 250, and then all over 1 minus a quarter. So so over here, I just want to change 36 by -18. So this will be, when we hit equal, this is equal to negative 24. So S250 here equal to negative 24. Note that these ones is the sum of the numerator, which consists of odd terms, and then this one is the sum of denominator. So therefore, the sum of the numerator over the sum of the denominator will be equal to 48 over negative 24, which is equal to negative 2. That's the answer. Thank you.